I'm here to talk to you about Neo Urbit. The Aries project began over 3 years ago. Directed messaging started 1 year ago. Shrubbery was conceived of coming up on 3 years ago now. And the spec for Urwasm, or the proposal, was written a year ago. We are now nearing the completion of the largest and most ambitious projects in the last decade of Urbit core dev. Largest in the sense of time, manpower, and also in scope. Yeah, like the directed messaging project has had 4 or 5 people working on it, which for Urbit is like a Microsoft scale project. And in fact, we are so close to being done with these projects that I'm even going to give you timelines. Yeah. All right, so here are the 4 projects I'm going to talk about. Aries, directed messaging, Shrubbery, and Urwasm. Together, these form Neo Urbit. So I'm going to go through them in order. Aries gives Urbit a fast interpreter and allows it to efficiently manage large amounts of data. It's a rewrite of the whole Nock interpreter and persistence mechanism, one of the 2 processes in the runtime. There are 3 major milestones for Aries: make Nock fast, manage big data, gotta get that big data energy, and Vera compatibility. I'll go into what all these mean and break it down a little further. So the first one is making Nock fast. And there are 3 stages here. The first is to complete SKA, which stands for Subject Knowledge Analysis. And once we do this, then Aries will be roughly comparable in speed to Vera. It's just about done. So we expect that to be done shortly. You can see in the timeline there by beginning of July. SKA, Subject Knowledge Analysis, refers to a novel static analysis technique for analyzing Nock code that makes it able to be run significantly faster. So this was devised by Edward Amsden, and Joe has also been doing a lot of work on that lately. So this is a sort of heroic effort to bring this over the finish line. Interesting, I was learning from Amsden that compilers don't normally do this kind of technique because normally it's too hard. Nock is actually simple enough that you can do this, which is pretty interesting. So that's the big kind of, the big speed up comes from that, but then it takes a lot more effort to sort of propagate the learnings from subject knowledge analysis into the rest of the system to make it actually go fast. So the second step here is an optimized noun code, and that's when we expect to see Aries sort of pull ahead of Vera in terms of speed. So notice that this is just after the first milestone, right? It's a small and like well-scoped piece of work. The noun code is like a bytecode, but instead of being a condensed, linear sequence of bytes, it's just a linked list noun. So it's similar to a bytecode, but a different, just a sort of less optimized data structure. But SKA is written in Hoon, and so the output is a noun, and so and the linearizer is also written in Hoon. The output is a noun, so it comes out as a noun. So this is what we got. The way that works right now incurs a log n hash, not even hash table, a treep lookup. You call it by calling get by in Hoon on every single function call. And so it's amazing that the system works at all with that kind of overhead. This is a problem that's very much in the stop hitting yourself category of performance optimization. So we know what to do to fix this. It's replace the labels with indexes so that you can index into an array, get O of 1 instead of log n, as it should be. So optimize the noun code. Our Aries will start to pull ahead of Vera a little bit. We don't know exactly how much, but it'll be faster. And then, so that's coming really soon. The next step after that is to take this noun code and actually turn it into a byte code. And so that's the last step here. And once that happens, we expect it to be much faster than var. You can see that that's expected by roughly October. What that basically means is take that list, the linked list of instructions, sort of high-level instructions that need to be interpreted, and just compress them into a linear bytecode format. Otherwise, it's very similar. But that allows you to do something like what var has with computed go-tos, or like a really hot loop without function calls, et cetera. So that really speeds it up. There is a step after that, and I would note that much like a boat, an interpreter is an endless money pit. And so you can always dump more money into making it go faster, and I would love to do that. But well, it should be pretty fast with this bytecode interpreter. There's a step after that, which is compile Nock all the way to machine code, native code on whatever processor you're running. Amazon's been talking about that for a long time. It's very much on the roadmap, but not slated for immediate target. Just to note that there's we still have a lot more work to do. The second step is for Aries, is to manage big data. And when I say big data, the current amount that the PMA can manage is 64 terabytes, which should be enough for anybody. So the PMA stands for Persistent Memory Arena. And that is the part of Aries that stores nouns. So it'll store your Arvo state, essentially, and stores them on disk, and then does demand paging to pull that data into memory as needed, and manage efficient differential updates to that. It's a novel system and very cutting edge. Uses a copy and write B+ tree, and sort of like a Frankenstein between PHK malloc and LMDB, doing something that people don't normally do, which is like a virtual memory pager. You could actually use it for something other than Urbit. Anyway, it's cool. I won't get into it too much. But suffice it to say, it was designed from the beginning to handle very large amounts of data efficiently. And the good news is it runs, it works. And so the immediate next step is to fuzz test the PMA. Fuzz testing refers to generating lots of random inputs very quickly, sending them at a piece of software, and trying to break that software. Right? Comes from, I think the fuzz comes from the idea of audio noise, right? It sounds like fuzz, right? So you're generating randomness, and you're trying to just generate tons of examples and make sure this thing can handle lots and lots of different inputs without falling over. So we're going to do that because this system has to be extremely robust. So automated testing in this form is going to be very helpful. So that's the current step that we're at. We expect that to have, to be sort of up and running and having done some fuzz testing by August. The next step after that is to implement garbage collection for the PMA to free up disk space. So at the moment, when Aries runs, it just uses more and more disk space over time. Each snapshot gets bigger and bigger, and there isn't really a way of freeing pages of memory, pages of disk from being used. So it just sort of accrues more and more, it accretes more and more disk usage. And the reason that, so you know this is like a 4-month project here to implement garbage collection, and the reason is that we can't just do a naive garbage collector and expect it to work in production, unfortunately. The easy way to do this is you say, okay, well, I'm going to just trawl through, do one pass over the existing state, and that whenever I see something that I haven't copied yet, go copy it into a new file, right? And so you go brrr, brrr, and you copy everything. This is called copying garbage collector. It's one of the simplest garbage collectors you can write. This would work. This is probably the simplest thing we could build. However, if you're storing 10 terabytes in your Aries, then a copying GC step will go and write another 10 terabytes or so. Maybe a little bit less if you're able to clean up some garbage, but you don't know that. And so then you can go and delete the old old 10 terabytes, but that's a lot of disk writes. And so if you're planning on doing this, once an hour or once a day or whatever, that might blow through your disk really fast for an SSD. So and it can take a long time and use twice as much disk as you want, et cetera. So we have to do something a bit more sophisticated that doesn't move everything that you have on disk, right? So if you have that 10 terabytes sitting there, most of that should stay in the same spot when you do the garbage collection. Getting that to work is more complex, and we'll hear more about that later this week. The last stage in bringing arrays into production is what we call VAR compatibility. VAR is our current runtime. I should have mentioned that at the beginning. So there are two kind of basic phases here. The first one is what we call VAR King compatibility, which will allow us to boot and migrate real ships. VAR, our current runtime, is broken up into two Unix processes. One is called the serf, one is called the king. The serf runs Arvo, so it runs Nock, and it maintains the persistence for that Nock, so it maintains snapshots. The other one, the king process, does input and output and manages the event log. Ares replaces the serf, but not the king. So when you run Ares, you're actually running the Ares serf and the VAR king. So there's a fair amount of work that needs to go into getting those two things to talk to each other in all the different ways they need to talk to each other. There's been a lot of work that's gone into this already, but we need to be able to boot a new ship into Ares, and we also need to be able to take an existing ship that's running on VAR and migrate that into Ares. So we expect that both of those to be completed by August. And then the next 4 months are getting to VAR feature parity. VAR just does a lot of stuff. There are a lot of little tools and utilities and that need to be, most of those need to be re-implemented in Ares to get to production. It's sort of a polish kind of thing. So for example, bar mass, the bar mass command measures the memory use of Arvo, right? We need to have that implemented in Ares so people can check how much memory they're using and where the different memory is being used. All right, so that's one example of several that need to be re-implemented in Ares for things like inspectability, debuggability, forensics, maintenance, et cetera. So that's the last step for Ares. And after that, once we hit that, then you should be able to take any ship on the network, whether that's a big publisher ship that's running an important chat, or whether it's running infrastructure like a Galaxy, or just on your laptop for messing around, any of the above, and you should be able to convert that into Ares or boot a new Ares ship, and that should be just fine, right? That should be well supported production level. So that's the target for December. There's going to be a series of alphas and betas before then, and sort of increasing levels of robustness and performance. There are 2 talks about Ares this week. So the first one is about the PMA from Barter Simpson. That's today, 4:15 p.m.
Actually, that changed. I think that's now Thursday.
Correction, it's now Thursday. And tomorrow at 10 a.m., Ritpub Sipsile, Edward Amson, we'll talk about subject knowledge analysis, which is that static analysis technique that's kind of the core of the optimization to get Nock fast. So that should be, both of those should be very interesting talks. The next project is directed messaging. Directed messaging allows the Urbit network to transfer data at gigabit speeds and more reliably establish peer connections. This is a rewrite of the entire networking stack. So everything from the Ames vein to the packet protocol to the runtime code in the I/O driver that actually interacts with Unix. Despite that, it does not change any of the interfaces to networking from userspace. So you don't have to rewrite any of your app code. It's just a drop-in replacement. Everything suddenly just gets faster and stops flaking out. We've broken this up into 4 milestones. The first is 200 megabit transfer speed, so 200 megabit throughput on the networking. The next one is bidirectional migration. I'll explain that. Directed packet routing, I'll explain that too. And maturity transformation, which I think is obvious to everyone. No, I'll explain it too. All right, so the first one is 200 megabit transfer speeds. This is done. And actually, it's faster than that already. And we expect it to continue to get faster as we get closer to deployment, and probably even after that. Many money pits to go around, really. I mean, you may not know that a lot of TCP stacks are actually implemented in hardware, dedicated hardware in the network interface control. Looking at you, Amadeo. All right, so that's the first milestone. Next one is bidirectional migration. This is something that we don't normally do in Urbit because it's usually so hard that it's considered intractable. But in this case, we actually can do it, which is cool. And this means that I can upgrade my connection with you from old aims to new aims. And then if we both decide that we don't like it, we can go back and we can downgrade our connection back to old aims. And then we can repeat it. So we can go back and forth, toggle it back and forth. And I would note also that that happens on a per peer basis, right? So like I can have a new aims connection with you, an old aims connection with you, et cetera. And we're taking the migration of aims state as seriously as we can possibly take anything, right? You cannot lose sequence numbers in Urbit. You'll have to breach. So being able to have that migration be rock solid is very important. And so we want people to be able to run the migration, roll it back, run the migration, roll it back, maybe even automate it, do it 100 times in a row until morale improves, et cetera. So we expect that to be done in roughly a month, mid-July. The next one is directed packet routing. And so this is intended to have more reliable peer connections than current aims. Current aims flakes out sometimes when trying to establish a connection to a peer. Sometimes this appears like aims being really slow, right? If you're like, oh, I tried to send something and it didn't get there for an hour. That's not because it was dribbling 1 bit at a time. It's because it actually just broke and then later unbroke itself, right, and fixed itself. But so this happens with current aims, and it's difficult to sort of resolve all of the edge cases of our current routing system, which we call crisscross routing. It's like, if I want to send something to you, I send something to your galaxy, which forwards it to you. And then if you send me the response, that goes back through my galaxy to me. So it's crisscross this way and then that way. Looks kind of like a W or an M, perhaps. The directed messaging project does not do that. It does what we used to call symmetric routing. I send something to your galaxy down to you. The response traces the exact same path through the network, but backwards. So it goes up back to your galaxy, back to me. So it's symmetric in that way, right? So it's just one path, both directions. This is actually the sort of primary simplification that's enabling all the other things that are good things that are coming out of this networking project come from switching to that routing system, actually. It sort of has rippling effects all throughout the stack. Joe can discuss this in a lot more detail, and he will. This needs to be finished. So we expect this to be finished by August or so. Finally, the last one is maturity transformation. And the purpose of this is to handle very large messages without crashing. There are some other secondary purposes. I'll describe at a high level sort of what it does. I'll try not to go into the details. So somebody might have to pull the vaudeville cane on me if I get excited. But All right, so the fundamental problem here is that an AIMS message could be up to, what's the max size, a terabyte?
Way more than
Well,
I can't say what the number is.
The max size is many terabytes for an AIMS message. Like I can send you one message. New AIMS, yeah, not old AIMS. Old AIMS is much, much smaller. I mean, you can try it. It probably, if you send them over like 100 megabytes, it might just fall over. I don't know. New AIMS can handle very, very large messages. And this matches the idea of arrays where you're storing really huge files. You need to also be able to send those with your personal server, right? And receive them. So, however, there's an issue, which is that the internet is old and only lets you transmit 1 kilobyte at a time. So they're basically, so what you need to do is you have to have, so you know, on either side, right, it's like I'm sending you a file, I have this giant file, I want it to be the case that you have this giant file, but we have to squeeze it through this tiny little tube and drip it out 1 kilobyte at a time. And the way to make this efficient and sort of solve a number of different problems is to batch it so that you have an intermediate size that's, let's say, 2 megabytes, 8 megabytes, somewhere in that range, so that instead of me sending you the entire thing in one go, my Arvo emits one big chunk into my runtime. That runtime dribbles the kilobytes to yours, which assembles a chunk and delivers that chunk into Arvo, right? And then when that finishes, we do another chunk, right? And so that chunking allows for much higher performance, or like much faster bandwidth, and then also download resumption, where if that stops and you have to restart it, you only lose up to 8 megabytes or whatever of a large download. I would note that this is a big problem in the current internet that basically nobody solves, despite many HTTP resume headers being introduced decades ago, but it still doesn't really work. BitTorrent does it, yes. But yeah, so we have the way this works. The reason we call it maturity transformation, which is a nod to banking, is that this is actually scale invariant the way we're building it. So any power of 2 chunk size will work, and it's composable. You can have a whole series of relays that go from 8 megabytes to 4 megabytes, back up to 16, down to 2 kilobytes, whatever you want. And the authentication is preserved across that. So anyway, that's a cool thing. Joe will talk about it more. We need this in order to actually handle large messages and handle them efficiently, and it will also bring, it should bring a throughput boost as well. Joe Master Morzad will be giving a talk about this called Lessons in Declarative Networking today at 2:45 p.m. Now let's talk about Shrubbery. Shrubbery provides a secure, namespace-centric programming model that makes composability real. And that's not all it does. It also makes anime real. Just ask Liam. There are 3 main milestones in Shrubbery. First is developer alpha, then developer beta, and then production deployment as a vein, a kernel module. Before then, Shrubbery is implemented as userspace and userspace. The Shrub runner is a Gall agent for now. So that's the final step. I'll talk about what needs to happen in order to get there, to get to deployment. The first thing is a developer alpha to be launched tomorrow. Liam, you ready? Liam says he's ready. This has a few things. It has a minimal integrated development environment. There's an app environment, and it has some documentation. So a number of people have been running Shrubbery and building things on it for a few months now, but it's never been intended. We've never said, hey, try it. And so as of tomorrow, we're going to say, hey, try it. Still an alpha, but you can play with it. So the next step is getting from the alpha to the beta, and this entails a few changes. So one is implementing root shrubs. And a root shrub is roughly a virtualized shrub runner. as a shrub. Think of like running a Docker container inside of another Docker container, but that doesn't suck. Once we can do this, so that's a fairly large like internal change to the shrub runner. Once that's done, then we're going to try to stabilize the API to shrubs, right? So like, yeah, what?
That's like stabilizing the interface between like the shrub runner and like kernel space, but like the interface between shrubs to each other, like to other shrubs.
Can still change.
It will not change.
It will not change. Okay, so clarification, it will stabilize but not entirely freeze the API between the shrub runner and the kernel, but actually the interfaces between shrubs will be pretty much frozen by that point. So sort of ambitious level of freezing, actually. So that's the first step there to get to beta. The second step is committing to persistence, or you might call that continuity. So in contrast to the alpha, right? If you write a toy shrub in the alpha and then the shrub runner updates, it'll blow away everything. You'll have to start over. So we're not going to have support migration during the alpha. Once we hit the beta, then anything you write, you'll be able to write a migration to the next version of Shrubbery. So that's when we're committing to persistence and continuity. And then the third thing is that the UI for Shrubbery, now, there can be many UIs, but there's one that's being built as intended to be the standard. It's called Sky. That's the UI there is going to stabilize for the beta so that, if you're a developer and you're using Sky to, write shrubs, mess around with the system, et cetera, the whole interface won't just sort of change under you like a Google search bar or something. So stabilize the UI. So that's to get to beta. And then the last step is getting from a beta to production. So there are four, just on timeline here. So the beta we expect to be mid-August. Production we expect to be next January. And there are four things that need to happen between the beta and production in no particular order. One is a service discovery layer, which is to say if you have, let's say, a wallet shrub on your ship. You may have many wallet shrubs, little programs that, that expose endpoints that act as wallets. With a service discovery layer, I can ask you, what wallets do you have on your ship and where? So I can discover what services you're running of a particular kind, a particular protocol. We've never had this in Urbit, but it sort of falls out of the Shrubbery model pretty nicely. Of course, you don't need to use this. Anyway, Liam will go into more detail. But anyway, that has to be built before production. Second thing is security. And this is really probably the biggest, sort of most crucial milestone in my opinion. Or it's a couple of them are like that, but this one's very important. And so Shrubbery is going to build an object capability system, essentially. So it's permissioning. And the whole idea of Shrubbery is that you can have a hierarchical tree of programs that are all sort of inside of each other. It's somewhat similar to a client-side component system, if you're familiar with that. But it's on the back end. And the general idea is that any shrub can constrain the behavior of its children. So it can limit what information its children are able to see, and also limit the effects that the children are allowed to perform. So input and output are both limited. What's nice is this is quite a simple model. And it's based on the way that Shrubbery does dependencies internally among shrubs. So that's the model for security on the back end, is roughly that each root shrub constrains its children, which constrain its children, et cetera. Which includes access to the kernel and access to other shrubs. And then the idea is that any legitimate front end for a Shrubbery system, including Sky, will mirror those back-end permissions on the front end. And so achieving, and so that's to prevent a back-end, a malicious back-end sub-shrub from delivering front-end code that tries to break out of the sandbox and do things that it wouldn't be allowed to do on the back end. We've called this the front-end sandboxing problem, and there have been proposals for how to deal with it with Gall agents, but nobody's ever really been happy with them. It's a difficult problem. Shrubbery, I think, makes the problem quite a bit easier. So any legitimate front end just needs to read the security metadata out of the back end and apply the same constraints on the front end. It's relatively simple. So that's security, and this is how we get what we've called user space permissioning in the past on the back end and front end sandboxing on the front end. The next thing is an interface between Gall and Shrubbery. So a Gall agent needs to be able to poke a shrub needs to be able to poke a Gall agent. Gall and Shrubbery will live next to each other in production for quite some time. And so it's very, very important that they can communicate bidirectionally. And finally, the last step to get to production is developer experience. So improving the integrated development environment, adding debugging tools, inspection tools, polish, better documentation, etc. So there's quite a bit to do there, but in general, the idea here is that when we deploy Shrubbery, we're deploying it for developers, and so it needs to be a sort of batteries included experience, right? Like as a developer, you pick up Shrubbery, you can immediately jump in. It's clear, there are examples, there are tools. It's a good developer experience. So all that has to happen before we deploy the Shrub vein, and again, we expect that to happen roughly January of next year. That's the timeline. You can learn more about Shrubbery tomorrow afternoon from 1:30 to 5:30 p.m. So get ready to shrub. All day I dream about shrubs. So that'll be a whole more like a workshop kind of thing. So get ready to build some shrubs and have some fun. The last project I'm going to discuss is Urwasm. Urwasm allows Urbit to execute WebAssembly programs, providing support for mainstream languages, for example, C, Rust, Swift, Python, many others. There are two main steps for Urwasm. The first one is stateless function calls, and the second one is write a shrub in Rust. So the first one, stateless function calls, what this will allow you to do is, let's say you have something that is just a function, but it's written in C, or most of them are written in C. But you want to, it's existing code that's out there in the world. You'd love to just run it in Urbit without having to rewrite it in exactly the same way and does the same thing, but probably slower until Aries gets really good, right? So think of like there are lots of things you can do with this. Think of like a Unicode library or internationalization library. A good simple one is gzip, right? Give a piece of data to gzip, comes out compressed, right? It's written in C. It'd be great not to have to re-implement that whole thing in Hoon. Just run the code that's out there. Cryptographic libraries are another whole category of thing. Hash functions, encryption, signing, all kinds of stuff. There's tons of stuff out there that you can just compile to WASM and run. And so that's the first step, is getting to there. So that is very close to working in a production manner, but there are a couple of things that make it not quite robust enough. The first one is that we need to ensure determinism in a couple of places that requires some effort. So one is floating point, notorious for not being deterministic. There is a solution there, but we have to implement it. And the second one is memory.grow, which is a piece of WASM functionality that lets where the guest code can ask for more memory from the host, and so that we have to be careful to handle that in a deterministic, replayable fashion. The second one, so that's the first thing that needs to happen is ensure determinism. The second one is we need some Hoon libraries so that you can call WASM modules from Hoon in an ergonomic way. So there's some setup and teardown when you're calling into WASM from Hoon. Think of any FFI system. You know, you do pinvoke on Windows, or like some JNI calls from the JVM, or was it Node JIP or whatever from Node, right? Like lots of things have this kind of functionality, and typically, you know, when you use that, when you call into an FFI, you have to set up the environment, you have to marshal some data in, you have to take, you know, run it, marshal some data out, maybe do some teardown, and so that's also true here. It doesn't look that much different from any other FFI system, but you know, if an application programmer is going to use this, what you really want is for any of those libraries that you're going to pull in, like, you know, gzip or whatever, you should write a nice little wrapper around it so that you can just call a Hoon function. So, you know, a client of the library can just call a Hoon function. They don't have to care that it's running WASM internally, right? They don't have to manually like set up a WASM module call and, you know, move the memory around and all that stuff. So for anything that you're going to pull in, we're going to need that kind of wrapper library. Sorry, they attacked me. So the next step is to not have just stateless function calls, but stateful function calls. And I'm not going to go into too much detail about what that means. Dazrag is going to give a talk just after this, and he can go into more detail. But roughly, it means that you need to persist WASM state across invocations. So you call WASM once, and then you need to store, you know, something about, like, you know, it's not done running. It's sort of in the middle of running something, and you need to call into it again, and it makes more progress. That's a significantly more difficult problem than just running it once, and especially if you want to make that efficient. Yeah, Dazrag is a very cool and somewhat novel system for dealing with that called Leah. He can describe that in more detail. But that's required in order to write a shrub in Rust. I'm sorry, that's the second step. Write a shrub in Rust. Not just Rust, but maybe Python or, you know, Swift, right? C, that's a funny one. Write a shrub in C. I like this actually. So yeah, these are the three things that need to happen in order for that to be a practical thing to imagine doing. But this is really kind of the end goal of pulling in WASM in general, is to say, you know, okay, someone's a noob, they've just heard about Urbit, they're interested, they want to write an application, but they only know Python, and they don't want to learn anything else. And so they should just be able to have a Python class called PyShrub, right? And you make a subclass of PyShrub in Python, and, you know, it has some event handlers, right? And you write them, and you're done. And then, you know, your Urbit just runs that. That should just work. You know, there should be a Rust trait called shrub, the shrub trait. You write something that implements the shrub trait, and it works. Right? Each one of these requires a fair amount of work, right? It's because you have to kind of, so for each language, it requires a fair amount of kind of machinery, both inside the language and in the WASM runner, to kind of plumb that whole thing through. But it's doable. We should do that for a bunch of languages. So that's the last one. I actually skipped the second one. Sorry, I missed it. So the second one is that you need to call Hoon from within WASM. And you really want bindings for that in the guest language so that it's ergonomic. So the reason you need this is, you know, if you're writing a shrub, no matter what language you're writing in, it's still running in Urbit. It's going to be dealing with nouns, right? And it's going to be dealing with Urbit constructs like, you know, Hoon, atom, auras, path parsing, path serialization, you know, generic noun manipulation. And there's a lot of library code for doing that stuff, but it's all written in Hoon. And so similarly to why we'd want to be able to call into gzip, you know, from Hoon, similarly, like if you're in WASM, you want to be able to call into, you know, flop a list, reverse a list, right, in Hoon. So it's a sort of, bidirectional FFI. And Wasm is designed to do this, and DOSREG's implementation supports it already. But the piece that's missing here is that you really want some Python bindings for this that are sort of standardized so that you know how to call into Hoon from Python, how to do noun manipulation, et cetera. And ideally, that actually lets you call into not just the Hoon standard library, but also application code in Hoon, right? You write some Hoon, you write some Wasm, and then you actually they can call into each other, both directions. So you really want all of these things, but then we really have this, then once we have that, then we can say, yeah, hey, come write a shrub in whatever language you're used to. It'll just work. So that we are expecting by February next year. That's when that milestone is complete. You can learn more about Urwasm from DOSREG Topload right after this talk. So I'm very much looking forward to that talk. So now here you can see at the bottom, you've got, these are these different projects when they'll complete. The way we're going to do this is, I'll get into that in a second. In 2025, Urbit will have an endlessly composable application model that's secure, can manage terabytes of data, can transfer data at gigabit speeds, and can be programmed in any mainstream language. Neo Urbit. Nice. Just to go back for a second, these will be a lot of rolling, developer-facing updates on the network. Release candidates, et cetera. And then there will be one big announcement about Neo Urbit. I mean, name TBD, but that'll be. We'll do some marketing at that point and say, hey, here, this is a new thing. Once we have all those together. So just to conclude, you can help with this. You can help quite a bit, all of you in this room. And I'm going to list some ways to contribute. The first one is you can contribute to the Aries Developer Alpha. The alpha is out. You can run it. So run it, play around with it. It is an alpha, so don't run your favorite planet on it, but you can play with it. Also, feel free to jump in, look through the GitHub issues, see if there's anything you can do. But even just trying it, playing around with it, very helpful. This week, you'll be able to write some shrubs. So I highly recommend writing a shrub. Take some time, learn the system, have some fun. In July and August, that range, you'll be able to test directed messaging. So going forward, that's something you'll be able to help with. You'll be a tester. That helps quite a bit. Like the more real-world usage all these things have, the more we can bulletproof them before release. And finally, start to think about if you could import Wasm modules. Anything, if you could import any Wasm you wanted, what would you build with that? Perhaps. Thank you. All right, I can take a few questions, and also you guys are free to leave. The next talk, when does the next talk start?
10 minutes.
10 minutes. So there's 10 minutes until the next talk, but so feel free to, mill around, or I'll also answer questions, yeah.
About the Wasm project, so that's something that is expected to be running Urbit side, client side, or both?
Urbit side. A lot of clients can already run Wasm, right? So the browser can run Wasm natively. There are, lots of ways of running Wasm from other languages at this point.
Is there something for the browser side? Is there anything that needs to be done to make so that you could run, for example, Hoon code in the browser?
The question is, can you run Hoon? Will you be able to run Hoon code in the browser? Well, you could try to compile var to Wasm or Aries. I don't know how well that would work. It's probably a fair amount of work to get it to work because both of them do a lot of weird Unix stuff that I would just not expect to work in WASM. But it's definitely a fun thing to think about. I think other people have thought about that more than me. There's also the Nock.js project. So there is a Nock interpreter written in JavaScript. And some work has been put into that. It has like an optimized jam and queue and I think like a trampolining system. It's not, you know, it's not purely a toy.
It compiles Nock to JavaScript.
It compiles Nock to JavaScript, and yeah, I think the big piece of work that would need to be done there would be to sort of productize that. I think to add a more efficient Jet dashboard.
It would be very interesting to integrate that with subject knowledge analysis.
Joe says it would be very interesting to integrate that with subject knowledge analysis. Yeah, JavaScript knowledge analysis. Yeah, what's up?
You said any legitimate front end will mirror the back end permissions on the front end. What kind of heavy lifting is that for legitimate?
Yeah, okay, so the question is, I had said any legitimate front end will mirror the back end permissions for Shrubbery. What?
What about an illegitimate?
What about an illegitimate one? Or like, what does it, you know, what does legitimate mean? And it's actually exactly the same as a browser, right? So the browser security model, you know, against cross-site scripting, uses the CORS, you know, cross-origin resource sharing system. Everyone's favorite part of writing web code, right? But it's there for a reason, right? So basically, that didn't always exist, and so it used to be that, you know, if I went to a malicious website, that would actually be, I think this didn't always exist. Joe or someone who, you know, has more experience can probably remind me of the history. But I think when originally you could just go and you could make a request to some other domain, and it would use whatever cookies and stuff you had in your browser. So basically, like if you just go to a website, then it'll like go and log into your bank and, you know, siphon all your money out, right? So that's sort of the fundamental problem of like a composable front end. Is like if you're pushing down somebody else's code on the front end, how do you make sure that that code doesn't do things that it's not allowed to do? And what it means to be a legitimate front end is that it prevents that from happening, right? So it actually like implements a security model like among the different pieces of code that are running in it, and so it honors the intent that the backend had to prevent that code from, you know, escaping its sandbox. So it's like, yeah, when you run a browser, you really hope it's a legitimate front end for CORS. And they are, basically. And so it's the same thing with this. Now, there'll be like a standard JavaScript library that's like a shrub runner front end that implements that. And so, you know, if you go and write, you know, some other thing on the front end, or maybe even a different, you know, like an alternative to Sky or something, ideally you should just have like that piece of code, or at least that logic that you can kind of pull in to enforce, you know, the security. So for us, it'll have to run as sort of, if you're running a browser-based front end for Shrub, you're going to need to implement, you know, that has to be implemented in JavaScript on the client. But ideally, that can be standardized.
Is there any like thought right now around like how one that's standardized, like users enabling like user sanctions, like illegitimate front ends, like reskins, kind of like would this prevent like something like Escape from like improving the UX of another app that has like?
Okay, yeah. It's a good question. So the question is there has been any thought put into client-side extensions or reskinning? Thought has been put into it, but not by me. So you're gonna have to ask Tiller Tolbus and Migrev Dulcig about that stuff. Yeah, it's a good topic to discuss tomorrow. Yeah.
I think it's just worth mentioning, like the legitimate front end that enforces these security properties might not have to be like the front end that you write. So you could write a front end into another legitimate front end that enforces security properties.
Yeah. Thank you. That's a good clarification. So Tiller says that it's really, it's not that if you go write a shrub that you have to implement the, you know, front end permissions for that shrub's front end yourself. It's that there's one library on the front end for like the front end's sort of like shrub renderer, shrub loader, and so typically, you know, if you just go to write one little piece, you don't have to rewrite that. It's only if you're rewriting like a whole front end system, like if you're going to go, you know, implement a native client in iOS or something. And then even once that exists, then each shrub doesn't have to recapitulate that. Okay, I think we should wrap up. Thanks, guys.